Welcome back. In this video, we'll try example 2.3.3. We're going to evaluate limits of types. It's still 0 times infinity. In this case, let me just add a few words here just to let you know these are challenge problems. All right, so they'll be more complicated than what we've seen so far, and you won't get 10 of these on an exam. You might get 1 or 2 at this level. All right, so let's try the first one. A limit is x goes to positive infinity of x times sine of pi over x. All right, let's evaluate both parts. X is going to go to positive infinity, and then the interior of sine, pi over x, as x gets really big, it's going to tend to 0. And if you remember, sine of 0 is 0, or you could use your calculator as well, the trig circle, the graph, whatever you're comfortable with. All right, so we do get infinity times 0. That means we have to use this method we just learned, and we have to bring one of the two factors to the denominator. We have to pick carefully, and here are the better ones. We don't have any of these. We don't have x to a negative power. We don't have any exponential. We do have x to the 1, and so one of our function is here. The other one is a sine, so it should be here. So we're going to take the x to the a. That's the better one of the two to bring to the denominator. And I'm going to get 1 over x. All right, I'm going to apply L'Hopital. I can because now I left a 0 on top. So that term was 0. And that used to be infinity when it was here. So I brought it down. It's 1 over infinity now, which means it's 0 as well. I can therefore apply L'Hopital. I'm going to take the derivative of each part. Let's just put a note on the side. Here, 1 over x is x to the minus 1. And so when I take the derivative, I'll get minus x to the minus 2. So that denominator is minus x to the minus 2. The top part, I'm going to use a chain rule. So I'm going to take the derivative of the exterior, and then I have to multiply by the derivative of the interior. And that derivative is the derivative of pi x to the negative 1. So these two are very close. The only difference is I have an extra pi in the blue one. So I get minus x to the minus 2. And actually, they're close, which means that they'll cancel, which is going to turn out nicely. All right, I'll get x goes to positive infinity, cos of pi over x, pi x to the minus 2 with a minus, and then minus x to the minus 2. A lot is going to cancel. What will be left is the pi and then the cosine. Cosine of pi on x. The rest, the minus and the x squared will cancel. So x squared cancels, the minus cancel, I'm left with the pi. And now if I plug it in, I get pi cosine of pi on infinity. Pi on infinity is 0, and so cosine of 0. So pi cosine of 0, that's 1, so I get pi. All right, so this one's, I'd say, a 3-star out of 5. It has a hard derivative here, but it's only applying L'Hopital once. It has only one hard step, really, to get these derivatives, but once you have it, the rest follows nicely. All right, let's try one with more funky functions. All right, so let's try this one. Limit as x goes to 0 plus of log of x times sine of x. Right? Let's evaluate it first. That's always the first step. You want to make sure that you don't work for ages for something that you could just evaluate by plugging it in, and that's it. All right. So here I get the limit as x goes to 0 plus. Oh, sorry, I'm evaluating. I like that it shows you definitely do it. Don't forget, and then I forgot. All right. Ln of 0 plus times sine of 0 plus. Sine of 0 plus is 0. Log, I mean, we've done it a few times. I keep promising this will be my last, but maybe not. So I won't promise anything. We are going to 0 plus, so we're approaching 0 from the right, and that means the curve is going to minus infinity. And so this is minus infinity times 0. All right, so we're in the right section. Now, I have the option of taking the log down and it becoming 1 over log, or taking sine down and it becoming 1 over sine. We like 1 over sine more because it's actually cosecant. We know it. We know its derivative, and it's not that bad. 1 over log is bad. All right, so it's not great, but not that bad. So we will take down sine. In fact, if you notice in the sequence, sine is pretty far along, but log is the last one. And so this is the one we'll pick. All right, limit, I'll leave the log on top, and I'm going to have 1 over sine of x. Let me write it as secant. I mean, you don't, cosecant. You don't need to. You could take the derivative as is, but we've already done the work in Cal 1 to find the derivative of cosecant, so might as well use it. All right, so now I've brought the 0 down, and so the limit turns into an infinity over infinity. The derivative of log is 1 over x. The derivative of cosecant, does anybody remember? Minus cosecant of x, cotan of x. All right, so I said that part A was a 3-star. 1, 2, 3. This one is definitely 5-star. All right. At this point, it looks like a mess. I have 1 over x, and I have minus cosecant minus cotan. Don't like it. If you plug it in, you'll get infinity over infinity still, so you could use L'Hopital. But what I'll do is I'll switch things around to make it nicer. The 1 over x, I'm going to think of it as an x in the denominator. That's going to be nicer. So let's write that down. In fact, that's going to be my whole denominator. Everything else I'll bring to the top. So I'm bringing x to the denominator. And cosecant is 1 over sine. And so if I bring it to the top, I'll have just sine. That's nicer. So let's do that. Cotan is 1 over tan. And so I'll bring it to the top. I'll actually get tan. Again, nicer. In fact, that's part of the reason I said if you have these functions and you're looking for something to switch from top to bottom, these are good because they go from we don't really like them to, oh, fine, this is fine, this is completely fine, I can deal with this. All right, don't forget the minus. And so this is the new limit I have. The top is sine of 0, tan of 0, that's all 0, and the bottom is 0 as well. And so I'll be able to take L'Hopital. I need the product rule for the top, right? So I have a product of 2 terms. I'm going to use the product rule. I'm going to get minus cosine of x. So that's the first term where you take the derivative of the first of the product and leave the second one alone. Then you're going to do the opposite. So minus sine is going to stay put, and then I'm going to switch tan to its derivative, so secant squared of x over 1. Now we plug it in. Minus 1 for cosine, 0, tan of 0, 0. Sine of 0 is 0. Secant is 1 squared 1. And so I get, sorry, I'm a tiny bit low on space. I'm just going to move that over. I'm sorry if you are low on space too, but the only thing you have left to write is 0. All right. All right, so this one was tough. It was tough because, I mean, I expect you to be able to do this and then write it as cosecant. And then this one's tough, but not so tough. I mean, there are formulas that you have in your notes from Cal 1. This is the hard step. And then you have a product rule as well. So 2 hard steps right next to each other. All right, good work. Next, we'll do section 2.4, and we're going to look at indeterminate of these types. So infinity minus infinity.